And the question. Okay, so the diagram above shows a sketch of the curve with those parametric equations. We probably recognize it as what kind of Cartesian in general. We suspect that it's what kind of Cartesian equation if they ask us.
Is it exponential?
I don't think so. I mean, exponentials tend to you know, they tend to curve that way or that way. But then, of course, they're negative. Yes, the point is, if you took the negative of that kind,
yeah,
then it would be looking more like that one. Of course, that's a sensible answer, but it's not the only sensible answer, and I suspect it's what's alternative. I mean, to me, it just looks more like a half of a parabola, albeit rotated from its quadratic
okay, yeah, okay. Yeah,
appearance. I expect that's what it is. But anyway, and of course, the rotation probably means that it's a root.
Yeah.
Here we are. Yeah, the actual question. That's okay. Find the gradient of the curve. Right. I took a second look at that. T is pi over 3 again, but that's coincidence. Right. Well, let's do that. Find the gradient of the curve at the point where t is pi over 3. Well, same process. Tell me what to write then. The gradient being, of course, what do we use to find the gradient?
Differentiation.
With respect to, if we can, because the graph is drawn on an XY grid.
Yeah.
We probably want, what expression do I want to write for the gradient function?
Is it dy by dx?
Yeah. We do want to know the rate of change of the y values with respect to the x values.
Yeah.
And from that funny version of the chain rule, we know that with parametrics, that reduces to what?
So it was it would be d. Sorry.
Yes, I mean, you might. Good for you if you're trying to derive it from the chain rule, but it's a reliable mnemonic that dy dx is just that top one dt.
Dt and then dx over dt.
And then dx dt on the bottom.
Yeah.
So in this case, what do we get on top?
In this case, on top you get 6 cos t.
Good. Over.
D. So it would be no 2 no. Minus 2 sine 2t.
Not quite. In outline, I agree with it, but notice that you've got a composite there. You've got the cos of the whole of 2t. You've got the cos of a function of t. Therefore, yes, it's going to be minus sine, and in fact, 2 cos will be minus 2 sine.
Yeah.
Of that. But remember what the chain rule says we must do immediately afterwards? Did I rub it out? No, here it was.
Yeah.
The chain rule says you must, having differentiated with respect to the inner function here,
Yeah.
see where I'm pointing? You must
Yeah.
multiply by the derivative of the inner function with respect to x.
Yeah.
So this is dy d blob,
Yeah.
in other words, dy du. But then here, we must multiply by du dx, the derivative of the inner function,
Yeah.
which is what?
The derivative.
What's the derivative of the inner function there?
Oh, it would just be 2
Yeah. So on the bottom, actually, we've got what?
minus 4 sine 2
Sine
2t.
2t still. Yeah, good. Because down on the bottom is still the blob.
Yeah.
So that'll simplify slightly, won't it?
Yeah.
To what?
So cos of a sine is
Well, it's sine of 2t, so we can't use tan or cot.
oh yeah.
I just thought 6 over 4 will cancel to, and we might as well put the minus. I mean, if we no, we could have the minus down there. That doesn't make any difference. But of course, 6 over 4 reduces to
3 over 2.
3 over 2. We'd rather write that.
Yeah.
Now, you know, we're going to substitute. We're going to think about the unit circle again and find the values of cos and sine of double that, and that'll be fine. Notice we could simplify this somewhat, couldn't we, by expanding. We know that a double angle formula, don't we, where sine 2t expands to what?
The sine one was. Oh, I forgot the identity.
These two do want remembering. Sine 2 theta, let's call it, expands to.
Oh, was it 2 sine theta cos theta?
It was good. I mean, those two do want memorizing. This one, of course, actually, it's only recently I've got into the habit of knowing all three of them, but still the one that's closest in my mind is which one? Any don't tell me what's in my mind, but any expansion of cos 2 theta would be what? Let's go from here to be sure. Okay, so you know, perhaps this is the safest version, as long as you say cos squared minus sine squared and not sine squared minus cos squared.
Yeah.
But as long as you get that the right way round, then you can see that it's going to fall out. Well, if you change it to both sine, you've got 1 minus stuff, and you can see that it would be a total of 2 sine squared that you're subtracting.
Yeah.
And that will be the same as having cos squared minus 1, but plus another cos squared is 2 cos squared.
Yeah.
So, so we could simplify this straight away somewhat, because then we can see. Oh no. Yes, because it's the sine version, because it's this one, we can see that that cos will cancel with that cos if we do that. So I think we ought to do that, just for the fun of it. So we've got minus 3 cos t, and it was going to be 2 sine 2t, is going to become how many sine t cos t? Oh, I shouldn't have hurried this. I shouldn't have done. Well, it's going to be 2 times the expansion of sine 2t, give me?
Cos squared equals sine squared.
No, that's cos 2 theta. Use this one.
Oh, I mean, yeah, 2 sine theta cos theta.
But they're t, yes. And let's simplify that then to
4 sine, well, 3 cos t
Yeah.
over
Right. But
4
we
sine.
can cancel the cos, can't we?
Yeah.
So really, we've just got
We've got minus 3 over 2, 3 over 4 sine theta. Yeah, 4 sine t, sorry.
3 over the whole of 4 sine t, or we could call it cosec t, couldn't we? Just to be difficult. Because sine is on the bottom there.
Yeah.
So let's use that one. We didn't have to. We could have done the previous unit circle thinking in both of those cases, but now we've only got one case to think about.
Yeah.
By the way, you can use cosec on SOHCAHTOA as well. You know, sine, according to SOHCAHTOA, sine is defined how?
Sine is opposite over hypotenuse.
So in that case, cosec, according to SOHCAHTOA, is?
Hypotenuse over opposite?
Yes, indeed. Yes, good.
Okay.
So going back to the unit circle, pi over 3, same diagram. So the sine was how much?
The sine, wait, what? Oh, the
pi
sine,
over 3, which was 1 o'clock.
Sine was root 3 over 2.
That's right.
And cos was a half.
Cos was a half. We don't need that though, because we cancelled the coses.
Yeah.
So we can just say, okay, if sine is root 3 over 2.
Cosec is 2 over root 3.
Indeed. Which, after cancelling, leaves us with?
A half times root 3?
Yes, root 3 over 2 again. That's weird, isn't it?
Yeah.
This turns out to be the reciprocal. Multiplying by 3/4 there gives us the reciprocal of 2 over root 3.
Yeah.
Funny. But it's good, isn't it? We've got 2 on the bottom, root 3 on the top. Yeah, sure. So minus root 3 over 2.
Yeah.
What did they want? That will be the value of the gradient of the curve at that point, yeah?
Yeah.
Because it's the value of the gradient function
Yeah.
at that point. Find a Cartesian equation of the curve in the form of y equals a function of x. Oh yes, because the domain is limited here, isn't it?
Yeah.
Stating the value of the constant k. All right. So on the assumption that minus k is at a minimum at one of these.
Yeah.
Let's ask ourselves for, you know, what's going on at these values of t. So at t equals 0, what are x and y?
T equals 0. I'm not sure. Wait,
Well, what time are we on the clock when the angle is 0? T is the angle.
Oh, we're at 3.
3 o'clock. And what would 2t be then?
2t would be...
Which has got nothing to do with it being 3 o'clock, pardon my... But we...
Yeah.
But the point is, we ought to ask where 2t is on the clock. But if t is 0, 2t is...
Is it 3 again?
Yes. I mean, basically, we're looking at 0. Okay.
Yeah.
We're still asking about cos of 0.
Yeah.
Okay. And let's look at the circle and think about cos of 0. Can you see what cos of 0 is from that diagram?
Cos of 0.
0 being 3 o'clock.
Yeah.
So we're just asking for the cos coordinate of the 3 o'clock mark.
Yeah.
Which is what?
1.
Yes. Cos of
Yeah.
0 is 1.
Yeah.
So x will be?
X will be 1. Wait.
No, cos of 2t will be 1.
Yeah.
So x will be?
I'm not sure. Wait, what?
Well, look what we've done. We've said we're assuming that t is taking the value 0.
Yeah.
Therefore, 2t is?
1. No, wait. 2t is 0.
And cos 2t is?
Is that 0 as well?
Oh, you're not following the steps here.
Of
You know, we're literally interpreting each bit of the text there. We're saying, okay, t being 0.
Yeah.
Therefore, 2t is?
0.
But then cos 2t becomes cos of?
Cos 2t becomes. Is that 1?
Right, but I said cos of what value, which is 1.
Of
Maybe I'm being pedantic here, but I'm saying t is 0.
Yeah.
Therefore, 2t is 0.
Yeah.
Therefore, cos of 2t is cos of
0.
0, which is?
1.
Cos of 2t is 1.
Yeah.
So 2 cos of 2t is?
2.
Yes.
Oh, okay, yeah.
Okay.
Yeah.
You know, we have to be that pernickety, don't we, with that? And at t still is 0, what's y going to be?
T is still 0. And 0. Is it going to be 6?
Because sine t therefore is what's the value of t we're taking?
Is it still 0?
0. And what's sine of 0? Well, what?
Oh, sine of 0 would be would it also be 1?
But where on the clock is 0 degrees or radians?
Is it 3?
3 o'clock.
3 o'clock. Yeah.
But then we're asking for the sine vertical coordinate of this point here,
Okay.
which is what?
Is it 0? Sine for sine.
That's right. That point there has got these coordinates, hasn't it? 1 horizontally, 0
yeah.
vertically, yeah?
Yeah.
So tell me the x and y coordinates when t is 0.
The x and y coordinates when t is 0. So that was 1, 0. So
You see
I'm
what we're
confused.
doing here? Yeah, we're trying to. We're saying, look, whereabouts on the graph?
Yeah.
The point where when t is 0. So we can just relate the values of the parameter t to the xy graph here.
Yeah.
Well, when t was equal to 0,
Yeah.
we got x equal to what?
We got that x was 2.
Yeah. And y was?
0?
Yeah, because sine of the 3 o'clock mark was the vertical coordinate of the 3 o'clock mark was 0.
Yeah.
So sine of 0 is 0.
Yeah.
6 times that is 0. All right. So I was only asking you to reiterate where we were with this.
Yeah, I know. I just.
So when t is 0, the x and y coordinates are
2, 0.
2 and 0. So we're here,
Yeah.
aren't we?
Yeah.
That's an x value of 2.
Yeah.
So it does look as though we can think of the xy graph as, you know, as t varies, we start at one end of it and end up at the other end. I thought we ought to check because that doesn't always happen with parametrics. You might be starting, you know, your t value might start somewhere in the middle or something.
Yeah.
Okay. And notice it's defined only for t values from 0
Yeah.
up to pi over 2. So we suspect that that's at the other end, don't we?
Yeah. Yeah.
But let's confirm whether that's true. So when t is pi over 2, what's 2t?
When t is pi over 2, 2 pi over 2, which is just pi.
Which is just pi. Yes. And so then cos of 2t will be cos of pi.
Yeah.
Yeah.
Cos of pi.
We're doing the same thing working outwards again, aren't we? From t, 2t, cos 2t, then 2 cos 2t. Yeah?
Yeah.
So, so 2t is what?
2t is was it 2 pi?
No. What was t?
T was pi, wasn't it?
I'm not, maybe you're not seeing what I'm doing here, which is investigating x and y values
Yeah.
for these extreme values of t.
Yeah.
So we did that for 0
Yeah.
to find out, just to confirm that a t value of 0 coincides with a Cartesian point, which is 2 and 0 for x and y.
Yeah.
All right. Now we're putting the other extreme value of t into these two x and y parametric equations.
Yeah. Yeah.
All right. But then we want to do this process again, don't we, of working outwards from t, 2t, cos 2t, 2 cos 2t.
Yeah.
Right? So, so what's 2t again at the moment?
Was it pi?
Yeah, why?
Because pi over 2 times 2 is pi.
Exactly. Good. So cos 2t.
Yeah.
T,
Is pi.
no, 2t is.
Oh yeah, 2t is pi.
There's the angle.
Yeah.
Use, 2t pi.
Yeah.
But then my question was, so what's cos 2t?
So it'd be.
So I don't want you to say pi again, do I? That's like saying cos of 30 degrees is 30 degrees.
Yeah. So it'd be
So we do want to think of the unit circle again.
Yeah. Oh, so it'd be cos and on the circle it would be 9.
It would be 9 o'clock. And the cos coordinate of the 9 o'clock mark is?
Minus 1.
Minus 1, good. Yeah. Okay,
so because of
x will be?
Minus 2.
Yes.
Okay, yeah.
And y will be?
Y.
What's our value of t at the moment?
Is it pi? Well, minus 2. Wait, no. Our value of
yeah.
Oh,
It's
so
like
T is,
you're trying to bat off the words I'm saying as though you're anxious about them.
okay, so wait, so T is pi over 2,
Pi over
and
2.
then
So
and then
90 is,
we want sine of a pi over 2,
and pi over 2 is what time on the clock?
pi over 2, it's 12 o'clock,
12 o'clock, and the sine value there is
1.
1, yes. So 6 sine t will be,
6.
yeah. So it does look as though here we've got -2 on the x-axis.
Yeah, and then
Y
6.
value of 6, yeah. I just thought we ought to check that so you get used to seeing how the two things translate.
Yeah,
Which
I'll get it.
do anyway.
Yeah,
Oh, and also they have asked for the value of the constant k.
yeah,
All right.
yeah.
So when we've done the main work here in part B, which is finding a Cartesian equation, do you know what Cartesian means?
Yeah, that, in the form y equals mx plus c.
Oh, only if it's a straight line. Which,
Oh, I mean, like it's like a normal
well, yeah,
normal equation.
x, that's what they're saying. In the form
Yeah,
y as a function of x only. Then we call it
yeah,
Cartesian, because Rene Descartes is credited with the invention of XY grids. They didn't use them in
yeah,
ancient Greece or anywhere.
yeah,
XY grids, they're only a fairly modern invention. In ancient times, really ancient times, I mean, if you don't think of, I mean, Rene Descartes was the 1600s,
yeah.
which probably seems ancient to you.
Yeah.
But before that, it was all geometry and not much algebra even, but not coordinate geometry. So it's
Yeah.
a fairly modern invention. Anyway, Cartesian equation, yes, the XY grid, as you say, or graph. And so the value of the constant k is, what do we call this statement here after the main thing? That's a statement of the what of the function?
The what? I'm not sure.
Well, notice it's the section of the x-axis which is being used.
Yeah,
So it's the section of the x-axis
yeah,
which supplies inputs to the function, because the
yeah,
y values are outputs, aren't they?
yeah.
So this is the set of inputs to the function. And what's that called? The set of inputs to the function?
Yeah.
What's the set of inputs to a function called?
What name for it?
There's a name for the set of inputs to a function, which is the section of the x-axis involved. Begins with D.
D. No, I don't remember. Oh, domain.
Yeah. They're asking us to
Find the domain.
find the domain of the function, yes.
Yeah.
Which is x values between -k and k.
Which is -2 and 2.
Exactly. K is 2.
Okay.
But let's do the main work of part B now and find y in terms of x.
Yeah.
Okay. So we'll start from the parametric equations, which are x equals 2 cos 2t, weren't they?
Yeah.
And y equals 6 sine t.
Yeah.
And see if we can get to expressing y just in terms of x.
Yeah.
Okay, do we have a plan?
Could you?
You need to think of, first of all, you know, whether you know it's going to work or not.
Yeah.
In the end, you might say, okay, well, I want y in terms of x. I do have y in terms of t.
Yeah.
So if only I knew t in terms of x,
Yeah.
then I'd have f in terms of x.
Yeah.
Eliminate the intermediary of t.
Yeah.
So can we turn x, or at least some of it, into into a function of x? Did I say turn x into a function of x? I meant, can we turn this into, can we make t the subject? Get t as a function of x.
Okay. So. Mm-mm-mm. So look for t. Oh, so could you divide x over 2 cos equals 2t?
Ouch! Are you thinking of cos of anything? Does cos theta mean cos times theta?
No.
No, 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 no. You know, you can't divide through by that part of it.
Oh, yeah.
It's not a part
Yeah.
of a product. So no. If we want to make t the subject here, what would be a good start?
Oh, divided by 2.
Wrapping this thing here.
Divided by 2. Divided by 2.
Divide by 2 because
Yeah. It's 2 times cos 2t.
yeah, timesing by 2 is the outer function. So to remove the outer wrapper, which is multiplying by 2, we divide by 2. Yes.
Yeah.
So we could say cos 2t equals x over 2.
Yeah.
Now, I think we might as well stop there. I mean, we could make t the subject here.
Yeah.
But then, you know, to get it closer to being sine t, we should really expand that in terms of cos and sine.
Yeah.
So whatever our motivation, actually, yes, let's do that. Maybe we're trying to, yeah. Even though we're trying to make t the subject, even if we were, yes, let's say, okay, cos t, expand it for me. Cos 2t, I mean, expand it.
Oh,
according to one of those.
which one would we want?
Yeah, up to you. Any will.
Cos squared take away sine squared. Oh wait.
Well, actually, I've changed my mind because the other one was in terms of sine only, wasn't it?
Yeah.
So let's use 1 minus 2 sine squared.
Yeah.
Yeah. So cos 2t equals 1 minus
2 sine squared.
2 sine squared of t. Sorry.
Yeah.
Equals x over 2.
Yeah.
Right. Good. Well, now, you know, if we can see a way to connect these, we could, couldn't we?
Yeah.
There would be different options here. I mean, in a way, we might even see we've got a quadratic. That might be the nicest way. Although, we've almost got, you know, sine in terms of x. And we've almost got sine in terms of y. Let's get sine t in terms of y. then I think you'll see a good way. Sine t equals
sine t equal y over 6.
good. And that gives us a clear option now, doesn't it? Can you see what we can do with that now? If we know that sine is y over 6.
So then we could 1 take away 2 times y over 6 squared.
Yes.
And then that equals x over 2.
Absolutely. Oh. So all that's left, because they wanted y to be the subject of a function explicitly in terms of x, we just need to make y the subject now.
Okay, so we can take the one to the other side.
Absolutely.
So then 2. Okay, so then if we square what's inside the brackets, we get
Yeah, you're doing a lot at once. Shall we say perhaps, we could say if x over 2 is 1 minus that, we could say that is 1 minus x over 2. That would be my preference. Anyway, do a little bit less than you were saying. Square rooting a bit soon is all I'm complaining about.
Yeah.
Then what?
So then, if she's, then could you divide everything by 2 on the right hand side?
Yeah, definitely do that before trying to square root. So what have we got on the right hand side?
We've got a half.
Yeah. Minus
Take x over 2 divided by 2. X over 4.
Good. Next.
And then we get y squared over 36.
Yeah. Okay.
Equals a half, take away x over 4, and
Good,
then
good.
we times it by 36.
Might as well,
then,
yeah, good. Yeah.
So y squared equals 18, take away 36x over 144.
Ouch. What's happening there? I mean, you were quite right to multiply a half by 36, which you did.
Yeah.
Now you're multiplying 4 by 36 instead of a quarter.
4 by 36. Oh, instead of a quarter, yeah. So so it'd be 9. So it'd be 36x over 9.
Why over 9?
Because
you didn't say over 18 here, did you?
There was an x. Wait, what happens to the x then?
So how are you seeing this? You're saying x over 4 times 36.
Yeah.
Isn't that 36x over 4? Or 36 over 4, lots of x?
Oh, yeah. Yeah, I was seeing it as 30. Oh, yeah. 36x over 4, yeah. So minus 9, so then y equals 3. Plus or minus 3.
Ouch. Is it true?
Oh, it's 9x. Oh.
Are you trying to say that? No. That's not true, is it?
No, I forgot about the x. I thought, yeah, okay.
Oh, that's not the problem.
Oh.
No, I do see. Sorry, you were simplifying that.
I was doing 18 take away 9, and then square root that.
Oh, right, okay.
So then y equals the root of 18 take away 9x.
Yes, I thought you were trying to split the square root.
No.
Not really. Fine. Yeah, that should be what they want.
Yeah.
And then write down the range of f. Do you remember what the range means?
The range. The range. Oh.
It comes together with the word domain, doesn't it? We
Yeah,
talk
yeah.
domain and the range.
Yeah.
Remind me what the domain is.
The domain is is the x-axis. So in this case, it's -2 and 2.
That section of the x-axis which supplies inputs to the function.
Yeah, inputs to the function. So
the range.
Is it the outputs to a function?
Yes. So it'll be a section of the y-axis which supplies the outputs.
Yeah, and would this be 0 and 6?
So how would you write it down?
I'm not sure.
You would say y values between, like here they're saying x values between -k and k. Here we're saying, therefore, y values between what and what.
Y value between is it not 0 and 6?
Yes. I mean, I know you told me that. I was just saying, how do we write it?
Oh, yeah.
I just want you to be conscious that you write it like that.
Yeah. Oh, yeah.
Because it's the range, and therefore it's the y values rather than the x values.
Yeah.
You have to be careful the way you say it. Although you might get away with it if you do that wrong. I don't know.
Yeah.
Okay. So that's that one, right?
Yeah.
And now this one.